Welcome back. As you know, I am Eli, the computer guy, and this is another after school special where we are going to be talking about caching in systems architecture. So, when we talk about caching in systems architecture, basically all we're talking about is when your system or platform talks with another system or platform and makes a request for information that your system will then save the results of that request locally so that in the future it can simply query the local data store or the local database instead of having to go out to that other system. So caching in systems architecture has become much more important over the years. Again, I started formally in IT in around 2000 and I got my MCSE in NT 4.0. So back in that time period, the architecture style we had was something called client-server architecture, and generally, more or less, everything was on your LAN, right? So you would have your facility. Within your facility, you would have your server racks. So you'd have your Active Directory server, your email server, your proxy servers, all that kind of stuff basically was in that server rack that you had. You would then have the workstations with your users, and basically your user at your workstation, whenever they needed anything, if they needed DNS IP address resolution, they could just very easily have their computer connect to the server. This all kind of automatically happen in the background, and there would be DNS resolution. Active Directory services, that resolution would happen quickly. Basically, since everything was on the LAN, communication between the clients and the server was fast, relatively secure, mainly because most people didn't know how to compromise a lot of these systems at the time, and it was reliable, again, because everything was on the LAN. Now, if you did have servers, like up in the cloud or at a different site, you would have things called replication strategies. So if I had a server at a different site, it would communicate with the server that I had on my LAN, and basically they would replicate data back and forth, anyways, back and forth. And this was a whole thing with databases and clustering and that type of thing, right? So you would have these different servers at different places, and basically they would communicate with each other and send data. That's where you'd have read database servers and write database servers and master database servers and read-write database servers, and a whole bunch of other stuff that we'll go into in other classes. But the important thing to understand is that for the user systems, and even for your servers within this infrastructure, everything was on the LAN, and it was fast, and it was reliable. So you really didn't have to worry about caching a whole bunch. Well, here's the thing, right? I'm going to tell you something shocking. I'm going to tell you something that's going to blow your mind. We're not in 2000 anymore. I know, I say things like that, and people are like, what? What do you mean it's not 2000? I swear it is. I wish it was 2000. I wish the election was Gore versus Bush. Remember when South Park made their episode, and it was douche versus turd sandwich, and we were all worried about democracy because it was Bush versus Gore. I remember those days. Anyways, right? So in the modern world, we've gone from client-server architecture to something called service-oriented architecture. And with service-oriented architecture, instead of having everything within your local LAN or on your network of some sort, you're going to be using services from all over the internet, right? You might be using identification services from one company. You might be using storage services from another company. You may have, your own cloud somewhere that provides certain services. And so when a user gets on their computer within the LAN, they're no longer simply going to the server on the LAN, but the server may be pulling information from all of these different places. Well, here's the thing. When you have your systems and you're pulling information from all of these different services that are out there, you have to worry about things like speed and latency to the other service, just generally on the network, right? What is the network speed between your site or your server and their servers. You have to worry about latency or lag with what if their servers suck, right? What if their servers are just really slow? So your packets get to the server quick, and your packets come back from their server quick. Their servers just suck, right? That can be a problem for your users. The other thing to be thinking about is things such as API calls may cost you money. So with service-oriented architecture, you're making what are called API calls, and so API calls are going to cost you an amount of money. So every time you're going off to connect to some service, that may cost you a penny or something like that. And so one of the things that you may do in order to try to reduce that cost is basically a caching system, so that your system, or when your person goes out, gets information from this API, from the service, when it comes back, you may want to store that into your own database or data store, so that in the future, when your user makes the exact same request and store it, instead of going out to this different service, it will simply go to your data store and pull the information directly out of your data store. Again, pulling information directly from your LAN, or at least from your local infrastructure, generally, hopefully, is going to be a crap ton faster than trying to pull it from somebody else's service. Another thing to be thinking about is something like a security concern. So remember, every time you make an API request to somebody else's service, they have what we call log files, right? They know what your IP address is. They know what information you're requesting. They know what information they're responding with. There's a whole bunch of information that they collect. So when your systems are constantly pinging the hell out of the API, they can also collect information about you. And here's the thing, in the modern world, information's money. I've been told data is oil. I think that's a load of crap, but anyways, I'm on YouTube and these people have billions of dollars. What do I know? So one of the things to be thinking about is if data is oil, every time you make an API call, they're collecting your information, and so they can then try to sell your data. Again, even if it's anonymized or that type of thing, they can sell your data, possibly to people like your competitors or other folks that may cause damage to your business. And so this is one of the things to be thinking about with caching. So basically what caching does in the service-oriented architecture world is when you go out to these services, all you're going to be doing, you're going to be making your request, they're going to give the response, and then what you do is you store the response locally or within your infrastructure, so that in the future, when your users or your systems need information, they go to your local data store instead of back out to the API. And that's good for saving money. That's good for performance purposes. That's good for security purposes, those types of deals. So let's talk about some actual use cases for caching within your architecture. So I have a main YouTube channel called Eli the Computer Guy, and on Eli the Computer Guy, what I'm doing currently is basically I'm using these modern technologies to build projects and then explain how the technologies work in order to actually solve people's problems, right? So I've been going to a lot of meetups, I've been going to a lot of events, and a lot of folks just keep talking about things like AI and quantum computers and robots. But they don't really talk about how this stuff is going to get implemented, right? LLMs are more dangerous than nuclear weapons. And then I'm like, how? No, seriously, how? And then people don't really know what to say next. And so what I decided to do on the main Eli the Computer Guy channel is to actually build things out so people understand this technology a little better. Again, when you say quantum computer, what does that actually mean? Quantum computers actually do a very specific thing. They're not magic, right? But anyways, one of the projects that I've been working on currently is my anti-Lewis Rossman robot. So I have a robot with computer vision. I set that whole system up with computer vision. And one of the things that I'm trying to add to it is the ability to talk to the robot to actually give a command, to actually verbally talk to it and actually have the robot give me verbal responses back. Like, wouldn't that be a really cool thing? And so I've been going along with this project, and one of the things that I've been doing is I've been using OpenAI, right? So basically I have a Python script. Let's just say it's a main Python script, and then I have a script of functions. And when somebody talks, when I talk to the Python script. So when I say computer, do something, what happens is my query and all the functions actually get turned into a string value, and that gets sent to OpenAI with a prompt that basically asks, what function is this query asking for? If I say, do I need a coat? OpenAI will respond with get weather function. If I say, is it late? OpenAI will respond with, get time function. If I say K or S, it'll also respond with get time function. So basically what I'm doing here, again with OpenAI, an actual use case for LLMs, is I'm using OpenAI to determine in natural human language, when somebody is talking to the system, what function they're actually asking for. Now, one of the issues with this, right, is that this is real human communication. I am talking to the robot. I am talking to the computer. And again, humans are impatient, and so we want things to work the way we're used to. If I talk to something, I want a response back relatively quickly. Well, here's the issue, right? So I currently talk basically to my computer. Functions go to OpenAI. Query goes to OpenAI. Then OpenAI has to process that information. It has to figure out what the hell I'm asking for. And again, this is fast. The connection between my computer and OpenAI is fast, and the connection between OpenAI and my computer is fast, but this still takes some time to process. Which, again, right, it's amazing, but it still takes time to get the response back. And so that is where we have a lag in this whole system. So one of the things that I added, a class that I actually uploaded yesterday, was I created a SQLite database. So SQLite is absolutely amazing. If you haven't started playing with it, we will have classes on that in the future. And basically, I have a database called Decision. So that's what it is, basically what the decisions are. And in it, I have an ID column, I have the query column, and I have the response column. And so what happens now is when I talk to my script and it gets the query, it will now go into the SQLite database. It will then do a select, all in query where the query is the query. So basically it's going to look and say, has this query already been asked before? And if it's already been asked before, instead of going out to OpenAI, it will simply give the response, the function response, directly back from the database. So this database is on the system, and so it's incredibly fast. So we go through the Python script, it gets the query, looks to the database. If it's already in the database, it pulls what the response is supposed to be, and then it goes through lickety-split. I don't have to worry about the internet. I don't have to worry about OpenAI, any of that kind of stuff. Now, if it's not here, so if the query is not in the database, it will then go to OpenAI with the query. When the response goes back, it will then write what the query is and write what the response is for the future, and then go through and perform the function. And then if somebody asks for the exact same query going into the future, that query is already in this table, and so therefore you will be able to pull the response. So the first time somebody says bonjour, this will go to OpenAI, get the response that says this is the hello function, and then it will run the hello function. The next time somebody says bonjour, it'll see that bonjour is already in the table, and so it'll see it's supposed to run the hello function, and then it runs the hello function. And so this is a caching system using something like OpenAI, and the value to this is, again, one of the things you have to be thinking about with API calls and service-oriented architecture is, again, what is fast, right? Having OpenAI do this whole parsing and figuring things out can actually take a few seconds and slow things down. So by adding this system, it increases the speed of this whole thing if somebody continues to ask the exact same types of questions. And the other nice part is, with a caching system, is if I lose connection to OpenAI, if OpenAI disappears, all the queries that are already in the database remain in the database. So even if OpenAI goes away, even if OpenAI just sinks into the ocean, So no new queries will be able to be asked. Any old queries will still be in this cache, and so this system will still be able to work with those old queries. And so this is something like that I literally actually built, and we have a video class that I uploaded yesterday in my timeline. So this is one of the things that you can do with a caching system. Now, one of the next things you're going to be thinking about with a caching system is basically attempting to reduce how many API calls that you have to make. So generally with API services, you are going to have to pay some amount of money. Now, it may not be a lot. It might be like $1 per 1,000 requests or something like that. But remember, at scale in production, $1 per 1,000 requests can get brutal really, really quick. Like that's one of the things with these APIs is for noobs or when you're testing, they can be very useful, right? They'll give you 10,000 requests per month for free. And it's amazing because you'll just never do that many requests for your crappy ass little system that you're creating. Here's the thing. You put that system into the company's environment that you're working for, all of a sudden 1,000, 10,000 users in that environment are pinging the hell out of that API, and all of a sudden that starts to be a large bill. And so one of the things that you should be thinking about whenever you have to make these API calls is essentially how long is the response for the API call going to be good for, right? So think about something like the weather. So I like, there's something called Open Weather. There's an Open Weather API. That again, they give you a whole bunch of API calls for free until you start using it for production, right? So imagine you have something like a web page or some kind of platform for your customers or for your employees. And one of the things that you do on there is you say what the weather currently is. One of the things you have to be thinking about with that is how often does this weather thing actually have to be updated, right? So you have your user goes to your platform. When this page is being dynamically written, it can make an API call up to Open Weather. It will respond with what the current weather is for this location, and it can then write that at the top of the page, right? Now, again, you think about this, and it's like, okay, maybe it's $1. It costs $1 for 1,000 requests or something. Well, if you get a website like Yahoo or something like that, and you got thousands or possibly millions of people going to your website, all of a sudden, $1 per 1,000 requests can get really expensive. So if you think about this, does the weather actually need to be updated in real time? Right? You make the request of what the forecast is. Do you really have to make that exact same API call every time a new user goes to your page? Or basically, could you set an expiration on the value that comes back to something like every 30 minutes? So the first person goes up to Open Weather API. You get back, it's 80 degrees and rainy or something like that. And then basically you set an expiration for 30 minutes from now. Now what'll happen is when the next user goes to your platform, instead of going up to Open Weather API, it will just grab that local information and they'll see it's, 80 degrees and it's rainy. The next person comes, they'll get the same information from that local cache all the way up until the 30-minute expiration time has expired, at which point the next user comes in. This is expired. You do a request to the Open Weather API, you get the response, and then it creates a new cache for the response with an expiration of 30 minutes. And so this is something that you can be thinking about. This can do things such as save money. So again, every time you make an API call, that's costing you money. If you are going to be a decision maker, if you're actually going to be a professional in the technology world, you need to be thinking about saving pennies, right? That's what a lot of people do. A lot of new people in the technology world, right? $10,000 is a lot of money. A penny is nothing. Right? Oh, if I have to spend $10,000, I'm really going to think about that. I'm going to do research and the whole 9 yards. But if it costs a penny, I'm not going to worry about it. The problem is you spend $10,000 on one server. That server lasts for 5 years. That server actually, total cost of ownership could be really, really, really cheap. Whereas this API call that may cost you a penny under load may end up costing you $1,000 a day, right? And so one of the things to be thinking about is as you build these systems out, from the day you build them out, ask questions like, how often does this API response actually have to get updated? Does it have to get updated immediately, every minute, every 30 minutes, every 60 minutes, every day? Right? Imagine for your platform, if you can simply make one API call a day at a penny, and then once you've cached that, you can then just provide all that information to all of your users, and it's not going to cost you any more money. This is one of the things that you need to be thinking about with these types of caching systems and why they can be valuable. The next real world use case of caching servers is something called Squid. I don't know if the cool kids still use Squid. Squid was awesome back about a decade ago. I do still know it exists. I actually haven't played with it a while, but there's something called Squid Proxy Server. And so basically what a proxy server does is it allows all the computers on your local network to use that one server as a gateway to get out to the internet. So web proxy servers is what came before NAT. There's something now called network address translation. It's been built into routers and modems for, 25 years at this point, so proxy servers haven't been a big deal for a long time. But before NAT, before network address translation, you had to build these things called proxy servers, and basically when you had a LAN, when you had your local network and you wanted your users on the local network to all be able to share one internet connection to be able to get to the internet, you would use something called a proxy server. So Squid proxy servers came around in that time period, and they still have their uses, definitely, but proxy servers aren't as a big deal as they used to be. But one of the nice things with Squid is that it can be a caching proxy server, which makes it a very, very sexy beast indeed. And again, if Squid isn't still around, look for basically caching proxy servers. So I used Squid back when I had my computer repair company. So many years ago at this point, I had a computer repair company. I had 9 employees. I had a building. I had billboards. Oh, I was going to take over the world right until I didn't. Anyways. So one of the issues that we had, right? So we had four workstations basically with my employees, my inside employees. There were 4 stations. Each one of those stations could support 4 computers at a time. And so at any one time, my technicians could be repairing 16 computers within our store. Well, the thing is, again, we were basically fixing Windows computers at a time. And so what is the big issue with Windows computers? And it's updates, right? Most people that were bringing computers to our store hadn't updated their systems. That's why they're getting viruses and malware. And if the computers were dead to the point that we had to do a wipe and reload, then we would do the wipe and reload, and we'd have to download all of those updates. And so again, you go back, 10 years, 12 years, you're downloading, 4 gig updates on 16 different computers, more or less at the same time. And that is just a freaking disaster. So one of the cool things you had with Squid caching server is basically you had the internet, you had the modem, and you had this Squid. We had a Squid server inside our premises, and then you had a switch that connected to all of these different computers that people were using. Well, the interesting thing was with a caching server is when one of my employees, so employee 1, would go to update the computer, right? So it would download, the latest service pack for Windows XP or whatever else. So this computer would go out to Microsoft, get the service pack, it would come in, and then it would go to this computer. And it was 4 gigs a number of years ago, so it would take 20, 30 minutes to do. Well, with a Squid caching server, as that service pack came in, it would actually store that service pack locally. When another person in the network, another employee would go out to McAfee, Now, to be clear, this was years ago. I want to be absolutely clear. McAfee used to be a good product. It's dog crap now, but it used to be a good product. So, anyways, one of my employees would install McAfee. They would go out to the McAfee.com to get the DAT files. That would come back in. That would go to their computer, and then the DAT file would get stored in this cache and proxy server. Same thing is true. Again, if we had Mac computers that needed updates, whenever that Mac computer updated, those updates would be stored within the Squid caching proxy server. And so what that means is that when I had one of my employees down here, employee number 4, and they had a computer that needed to get Windows XP Service Pack, what would happen is their computer would make the request. The Squid proxy server would see that it already has that service pack basically sitting within its storage, and so it would then send the service pack from that local server within our LAN. So now instead of worrying about internet speed connections and latency and lag and Microsoft servers being slow and everything else, since that service pack was already stored within the Squid proxy server, we were now able to grab it locally. So it went from 20 or 30 minutes to download a service pack to literally 30 seconds to download a service pack. And so that's one of the things that we use within our infrastructure. And I've got to say, I do not understand in the modern world why Squid proxy servers, caching servers are not more used, why these are not built into a lot of especially residential modems and routers, because I can tell you it was absolutely an amazing thing to have. And so this is something to be thinking about, again, with your infrastructure, with your architecture. If you have multiple sites, that type of thing, do you have files and such? Now, when somebody makes a request, that request can then provide that file to the user, but at the same time store that file locally so that the next person that needs the exact same file will be able to get it locally. You will see something called content delivery networks. So content delivery networks are used in order to provide things like video services. So YouTube uses content delivery networks, Vimeo, the whole 9 yards. And basically with content delivery networks, what it is these companies, right, they'll have their main data store. So they'll have their main server farms wherever. And these main server farms are replicating video files and such back and forth. But then they'll have edge servers. And so what these edge servers are as close as possible to the end user as they can get to reduce latency, right? So if I have a user here, if he has to go all the way to the main server, if his network communication has to go all the way to the main server and back, the latency, I don't know, they say it'll be high in the modern world. Who knows how high it'll be, but they think it's going to be too high. So what they want is they want the user to go to an edge server that is as close as possible to them because there will be less latency. And so one of the things that the content delivery networks do is when you request a video, it will see if that video is in that local edge server. If it is, it will simply provide you that video from that local edge server. If not, it will then route the request back to the master server. The master server will then send it to the edge server of the content delivery network, and then it will go to the user, and it gets stored in this edge server. So the next user that wants a video, when they hit that edge server, they will just get it directly from that edge server. It won't have to go back to that master server. So think about like when the next Game of Thrones video comes out from HBO or whatever, they'll seed that in their master servers. And then as people make a request for that show, it will then get pulled to the edge server that's closest to them so that they can watch it. And then when people, other folks, hit that same edge server, they'll be able to pull it from the edge server, then all the way from the master server. And what's good about this kind of infrastructure with caching is that if you have servers where nobody's asking for that particular video file, then the video file isn't sent there, right? It's an automatic process. As people ask for something, it gets cached into the storage. When the next person asks for it, it comes from that local storage instead of from the master file. But if nobody asks for it, there is no bandwidth between these systems. So again, this is kind of one of the things to be thinking about with caching systems and dealing with files, especially large files. Now, another situation where caching can be useful, especially in the modern world, is with DNS, domain name services or system or something. We just call it DNS and we let the kids argue about what the hell that actually means. Anyways, basically what DNS does is it resolves what are called fully qualified domain names to IP addresses. So it'll resolve CNN.com to, I don't know, 201.88.44.2, right? So basically, the computer cares about the IP address, a TCP/IP4 IP address. It doesn't actually care about CNN.com. And so what happens is your computer, so you have a DNS servers, and you have your computer, and then you have CNN.com at this IP address. So your computer, when you want to go to CNN.com, will go to the DNS server. It'll say, what is the IP address? The DNS server returns what the IP address is, and then your computer then goes to that IP address, which will then provide CNN.com. This is a whole complicated system. If you don't understand it, don't worry about it too much. I have many classes on things like DNS, right? Well, here's one of the interesting things. We live in the modern world, and you may have heard those before, but people think data is oil. Again, whether or not trying to collect all of this data is causing more problems than it is ever worth, it doesn't matter. When something gets into geeks' minds, they just do not let go of it. So here's an interesting thing. To think about. When your computer goes to that DNS server and requests the IP address, what can this DNS server do? It can have its own SQL database of some sort with tables and store a whole bunch of information. It can store the IP address of the computer that's making the DNS request. That will tell their systems what your general geographic location is. It'll say what your who your ISP is, and a whole bunch of different information. There's latitude, there's longitude, there's a whole bunch of interesting stuff in there, right? And it can then also put what site you're going to. So somebody at this geographic location, with this particular ISP, with this particular computer, the operating system of the computer is going to this particular website. They can then collect all of that information, and then what do? They sell it, because of course they do. Again, remember, when China uses TikTok in order to collect information about Americans, that is horrible. That's the start of World War III. When China goes to ISPs and purchases data wholesale, that's capitalism. Again, I do not understand. People are like, Eli, you just don't understand. I'm like, no, so much of this I do not understand. So TikTok is going to get banned out of the United States because people are worried that they're spying on us. And yet these companies can literally sell our information wholesale. It is shockingly easy to de-anonymize this information. And that's just fine and dandy. Literally, intelligence agencies are literally buying this information today. So anyways, one of the things you do is you can do caching, again, in order to try to limit the risk. Again, if you're going to be using the internet, TCP/IP4 is a horrible protocol. When you're talking about security, when you're talking about privacy, when you're talking about so many things people in the modern world care about, you shouldn't do that with TCP/IP4. You'd be like, I want privacy and security from my yodeling network. I mean, again, imagine that. Imagine you have this network of yodelers up in the Swiss Alps, and then people started complaining that it wasn't anonymous and private. And you're like, yes, because they're yodeling in the mountains. Yodeling is not private. It's not secure. It's not, of course, it's yodeling. Yeah, to be clear, TCP/IP4 is very much like yodeling. But anywho, one of the things you can try to do, though, is you can try to mitigate the risk, right? So again, instead of your computer always going up to a DNS server in order to do the resolution, basically you could have a local DNS server that has caching in it. So within your LAN, so within your premises, it can have caching so that when your computer wants to resolve to CNN.com or whatever you want it to resolve to, it's able to do that resolution from the local DNS cache in the local server to be able to go to whatever website they want so that the information does not go into the DNS of the whatever the DNS service provider is that you're dealing with. And so this can be one of the things to be thinking about, again, when you think about privacy, especially in the United States. So one of the weird things is I have a viewer base all over the world, and yet everybody thinks the Constitution applies to them, which is bizarre. I get like Romanians. Romanians love to argue about the Constitution for some reason. And it's like, okay, this is interesting, but you do know you're Romanian. Here's the funny thing. Whatever the U.S. Constitution may or may not do, it really doesn't have a damn thing to do with Romanians. And so an important thing, right? We get a lot of people, rah, 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 here in the United States, rah, NSA, Echelon, Snowden, all of that kind of stuff. And that is what it is. Feel free to argue. Feel free to argue. Feel free to scream. Whatever. Here's the thing. Not so worried about it. But what if you're a resident of Syria? What if you're a resident of Iran? What if you're a resident of, I don't know, North Korea? Now, think about, you're not necessarily going to CNN.com, but what if you're going to Voice of America? What if you go to the Tor.com webpage? Think about this. Before you can use Tor, most likely, you've got to go to the Tor webpage and download it. Right? That information can be stored. The IP address at this geolocation went to the Tor website after they went to the Voice of America website, after they went to who the hell knows what website. And so if you have intelligence agents in these countries, and all they have to do is do some basic analytics off of these kinds of tables, they can very easily figure out the people that might not be, the biggest fans of whoever the current politicians are. And as I always say, right, in large portions of the world, right, in the United States, everybody's worried about things like breaking passwords. We use 5 gazillion bit encryption. Eli, you don't understand. Our systems are so secure. We use 5 gazillion bit quantum encryption, whatever. That's great. Here's the thing. If you're in some of these other countries, I don't need to break your password. I just need to break your fingers, right? Because there's a password. There's a password. All I need you to do is get me to tell you the password. I don't need to crack your password. I just need to crack your kneecaps to the point that you give me your password. So if your information is being stored here, somebody shows up at your door and you go, oh, no, I'm not doing anything wrong. 3 months later, your computer may be opened up and you may not be looking very good. An interesting thing, even here in the United States, again, a lot of people, again, with encryption and passwords, again, the garbage people talk about, right? Encryption makes it all secure. There was a police officer, I think it was up in Philadelphia, and so he was being accused of collecting child pornography. And so he had a hard drive that was heavily encrypted. It was heavily encrypted. Local police department is what it was. They didn't have the IT resources to be able to crack the encryption, and it may not have been actually crackable at the time. Well, here's the thing. The police department was damn sure that the child pornography was on that hard drive. And so what the judge did, the judge literally threw the police officer into jail for contempt of court until he gave the police department the password to get into the hard drive. So it's like, if they get into your hard drive, you're going to go to jail for child pornography. If they don't get into your hard drive, you're going to go to jail for not giving them the password. Notice how your ass is still in jail. And again, this is an important thing to be considering with this whole modern world of technology. Is so many times geeks, really hyper focus on encryption standards or whatever else, and they kind of forget a ball peen hammer can do some amazing things to get information out of folks. And so, if you're in certain areas, or if you're looking at certain types of information, something as simple as a log that shows your IP address, what sites you're going to, and what computer you're using to go to those sites could be very valuable. And that's why you might want to use something like a caching server, even for something like DNS. Now, the final concept that we're going to be talking about today with this whole caching servers is if you're running something like a content management system. So you talk about content management systems, you're talking about WordPress, Drupal, Joomla, those types of things, right? The types of systems that run basically the sites for newspapers, magazines, webzines, that type of deal. So with these systems, generally it's not static pages anymore. It's all dynamically created where you have templates of some sort. You have a database that stores the articles and the information. And when a user goes to access a page, that page is dynamically written whenever the user goes there, right? So basically you have your server, so you have your Apache server. In this, you have a SQL database, you have your Python, or you have your PHP. And so what happens is you have a user. Your user is at their computer. They want to go to something like CNN.com. They go to the server. Through all of this, basically, it does SQL statements against a SQL server, it goes to templates, and it dynamically writes out the web page for the user, right? So the current news is blase, blase, blase. Well, the interesting thing with this, and something to be thinking about is again, load, right? Load on systems. So if you have one user going to your crappy ass server and it's dynamically writing these pages, it's going to be fine. It's going to be fine. If you have 10 users going to your server and it's dynamically writing these pages, you're going to be fine. 100 people, probably. 1,000 people, probably. 10,000 people? Imagine if you have a popular web server, or there is a popular article that came out, something big and fancy in the news. And so you have 10,000 people, more or less at the exact same time, going to your web server, and your web server has to dynamically write all of the web pages that they're going to and send them. Right, so there's the request to the SQL server, there's a request to data store for things like pictures and all that kind of stuff. That all gets packaged and it gets sent, and this is dynamically done every single time. Well, that's going to take CPU, that's going to take RAM, that's going to take IOPS from your storage system. Again, once you start getting enough users doing that, that load goes up and up and up. So one of the things you can do with a caching system is you can actually essentially dynamically write static pages. So let's say, again, you have your Apache server, you have your SQL database in there, you have your Python script or whatever else. Basically what you can do is you can fire the Python script to go to SQL, and then you can actually have it dynamically write static pages, right? So if you create the index page, it will just create an index.html page with all of the information, an about page with all the information, the current news page with all the information, the RSS feed with all the current information. And then when the user goes to your server, instead of it dynamically creating the page for every user, it can now simply route you to the static page that was previously dynamically created. So it was dynamically created, it was stored as a static file, and now that static file is sent back to the user because that's what the user cares about. And so this is one of the things to be thinking about with modern CMS architecture. More and more of this is being used because of the loads on these platforms with so many people going to it. Basically, sending a static file requires far fewer resources than dynamically creating a page whenever a user goes to it. So again, you can have your script go through, and every half an hour, every hour, every 24 hours, it can dynamically go through, write all of of these static pages, update everything, and then present those static, essentially cached pages to the end user instead of dynamically writing things. And so this is another style of caching system where this is all on the platform side, again, to reduce resource load from the users that are interacting with your systems. So now, having talked about a number of different uses for caching systems, let's talk about some of the problems you can run into with caching systems and basically things to be thinking about from a configuration standpoint. The first thing to be thinking about is cache expiration, right? So especially with that thing like weather, right? So if I'm going to make an API call up to open a weather's API, pull down the weather information, one of the things that I have to ask is how long should that information be good for, right? I don't need to necessarily pull that information every time a user makes a request, but you also probably don't want that weather report sitting around for 3 days either. And so that's one of the problems that you can run into. Again, like with a weather thing, it's not so significant. You probably hit, let's say, the 30-minute mark for expiration, and you should be fine. Where this becomes more interesting in things like network infrastructure is, again, with things like DNS caching. So whenever you change your DNS name with GoDaddy or with a registrar, one of the things that they will warn you when you change the DNS information is that it can take up to 24 hours for that DNS information to fully propagate. And so why that is there are, God knows how many, thousands, tens of thousands, hundreds of thousands of DNS servers out there. And so when you change your DNS information within your registrar, it will take a while to propagate out to all of these different servers. So generally nowadays it takes an hour or less, but you might be in some weird place where it takes a lot longer. And so one of the things to be thinking about, right, if you create that DNS caching server, what happens if the site that your users are trying to go to, they change their IP address for some reason? How long will it take before your DNS system basically flushes the old information and goes out to get the new information? Do you want that every minute? Do you want that every 5 minutes? Do you want that every 30 minutes? Do you want that every 24 hours? So the further out it is, the less information you're giving to the DNS service providers, but it also means that if there is an update with some site that you're going to, that will take a lot longer before your system will get that updated information. You start thinking about that with like software as a service providers, Salesforce, something like that. You cache Salesforce's IP address. Right, they may have lots of IP addresses. There was one time I was looking at like what the local IP addresses were. They had something like 14 IP addresses locally that you got redirected to based off of whatever reason, right? So let's say they have 14 IP addresses in your area. Your DNS caching system caches one of those IP addresses. It works fine for a few days. All of a sudden, nobody can get to Salesforce. The reason is they pulled that IP address offline for whatever reason. Your cache expiration is set to an hour, 5 hours, 6 hours, whatever. And so basically that will not get updated until that expires. And so that's one of the things that you need to be thinking about whenever you set up these systems is how long should the cache last for. The next problem that you can run into is something called cache poisoning, right? So remember, hackers are out there and they look at your infrastructure the way other people look at Sudoku, right? It's an interesting problem to solve. It's an interesting nut to crack. Unfortunately, they're trying to crack your infrastructure. So the consequences of being cracked can be much worse. And so one of the big problems we run into in the modern world, right, is people think about their architecture, they think about their infrastructure so linearly, right, that they secure the things that they're thinking about, and they're not thinking about how somebody could come in essentially through the back door and cause your system's problems, right? So let's say you have a server here, right? So you have a server here. Oh, and you have some kind of API that you're accessing, and so you have a secure connection between your server and this API, right? You got SSL, you got some other encryption or whatever going on, and so, your IT professionals make sure it's like, okay, so my connection between here and the API, that's secure. I make sure all the switch ports are blocked off. make sure there's no, there's no man-in-the-middle attacks or whatever. I have this stuff going on. But then they start thinking, oh, but maybe I could start doing that caching thing. Eli started talking about caching, right? There is a lag, there is latency here. So what if we create, our little database server over here? And we can start caching information into this database server. So you might be caching DNS queries, IP address queries into this database server. Again, it may be a Squid proxy server. Maybe you're caching files, service packs, those types of things. Well, basically, what DNS poisoning is, what cache poisoning is a hacker is looking at this and they're like, damn, that's pretty secure. I want to screw with these people's network's communication, but their communication between the API or whatever else and their server, it's encrypted. There's no way to get into the middle of that. I can't do anything with that. So how can I screw with their system? Well, if I know they've got a caching mechanism here, what if I can access their database and I can modify records in their database? So what if this is an infrastructure environment and I, as a sysadmin, am stupid enough to use SQLite as my caching database? Oh, wait a minute, what are you talking about, Eli? I thought you liked SQLite. I love SQLite. To be clear, I absolutely adore SQLite. SQLite is awesome. We're going to be having classes on SQLite. It is great. You know what is not? Secure. Damn near no security. Like, you actually have to tack on security, and I'm not sure I would trust the tacked on security. That's what's great. Basically, it's as easy to use as a text file with all of the power of SQL. But at the end of the day, basically, it's a text file. So if somebody is able to get into the terminal, command line, or something else, basically, they can very easily modify this SQLite, the records within the SQLite table, to whatever they want. So basically, let's say you have Salesforce. So you have a Salesforce record, and you've cached that as 206.44.55.1, right? Your users went up to Salesforce. This was the IP address. So now all of the other users are going to be directed to this IP address because that's what's in the cache. Now I'm a hacker. And I would like Salesforce credentials. Oh, might I have your Salesforce credentials, please? That would be ever so lovely. So if the cache is in SQLite and a hacker is able to get command line to be able to access this, because this is just sitting on the server, they might be able to modify. So instead of going to 206.44.55.1, they're going to have you go to 101.66.4.5, which essentially routes to some kind of Linode VPS server that looks like Salesforce, but it's just kind of off. It's Snailsforce. And then your users are going to get redirected to snailsforce.com. They're going to be asked to log in, and they're going to plug in their little usernames, and they're going to plug in their passwords. And then it's not going to work because they're going to plug it in and again and again. And so you get to verify it, right? It's self-verification. The user plugs in the username and password once, and it fails. Crap. So they plug it in again, and it fails. Crap. And they plug it in again, and it fails. See, you as a hacker can then look, okay, we have verified this is their username, and we have verified 3 times that this is their password. So now we're going to use that to go into salesforce.com or whatever else and cause all kinds of hell. And so that's one of the problems you can have with cache poisoning. If somebody is able to compromise this, right? So if you're going to be using a database for this type of thing, you're going to want to make sure it's secure. Again, Postgres or MySQL. You want to make sure there's firewalls in between. You're going to make sure that the privileges are up to snuff, and a whole bunch of different things. The other thing, again, if you're using that Squid, using a Squid proxy server, the cache is basically just a file. You got a file with a cache in it, and that has, the service packs and all that stuff that gets stored. So again, if I'm a hacker, how can I compromise 1,000 systems within your infrastructure? Trying to redirect them to a bad Microsoft site might be a pain in the butt. But if I can somehow get into the file structure of this caching server and swap out the good service pack with a compromised service pack, and now every computer on the network that goes to update will get that compromised service pack, that is a way to go after all of these different systems. And so that's one of the things to be careful about with these caching type infrastructure, is really think not just how you build it, but then thinking about how you secure it. Is your caching infrastructure secure? Because again, this is a good way for hackers to go after you without, right? You're so focused linearly on how this communication is supposed to work. It's real easy to miss this kind of thing. That's what we see with ransomware. I personally think more sysadmins don't need to go to jail. Again, I say some controversial things. I think more sysadmins need to rot in jail for a year, because what we see with a lot of these ransomware attacks is, what you'll notice with these ransomware attacks is that they'll come out and they'll say no data was compromised. No data was compromised, but the database is encrypted. What? That doesn't make sense, right? So the hacker was able to get into the database, but the data wasn't compromised? That doesn't, if they were able to get into the database, then obviously the data was compromised. Well, here's the thing, right? There's the database connection. So you have your web app or whatever app, makes a connection to the database. You know, you do your selects, you do your inserts, you do your updates, whatever else, right? So there's a connection, right? So there's privileges, there's a user account that's used, there's a connection account that's used, all that kind of stuff. One of the things that people forget about is that that database is actually a file. It is literally a file. Just like you have a movie file or a picture file or any kind of file. It's just a database file. And so that database file, right, is just sitting in a folder. There is a folder that contains a database file. So if a global system administrator checks their email while they are logged in with global sysadmin privileges, right, again, in an Active Directory infrastructure, and they click on a phishing email that then is able to run some kind of script using the privileges of the person that's currently logged in as a global system administrator, they are able to access the folder with the database file in it and then encrypt the entire file. That is how a database can both be hacked and encrypted, but the data technically remains secure at the exact same time. And the reason is because a sysadmin needs to rot in jail for a couple of years for their gross negligence. And so this is the kind of thing that you need to be thinking about. So many times when we think about security, we think about web app security. Again, SQL injection attacks, man-in-the-middle attacks. There's all this stuff. How do we protect from the front end of the web app to the database? All of that kind of communication. And then some global sysadmin decides to check their email while logged in as a global sysadmin, and everything goes to hell. This is the kind of stuff that you need to be thinking about with any kind of infrastructure that you're going to be building. Now, the final concern you need to be thinking about when you're thinking about caching services within your architecture is basically what hardware is going to be running your caching services, and have you audited it or verified it lately, right? So when we talk about things like DNS caching, right? Let's say you have a small company, a 10, 20 person company. You have, whoever the head of IT is for the company, basically whoever knows how to use Linux is now the head of IT. And so they decide they're gonna use a Raspberry Pi as a caching server. They're like, wow, I saw this video from Eli the computer guy, and Squid caching proxy server is amazing. So I'm just gonna spend, $55 and we're gonna have a Squid caching proxy server too, right? And that might not be too bad. I don't know, you got 10, 20 employees. You have 10, 20 employees, updates or whatever. Doesn't really matter how long it takes for those things to update. Like faster is faster. Like, right? This kind of thing might actually work for you. One of the things you have to consider, though, is depending on what kind of caching that you're doing, and depending on what the load is. as your systems grow is that these caching services are server services just like email services or Active Directory services or VPN services, right? The more load on the server services, the more load there's going to be on the hardware resources. And if you're using a $55 computer to provide caching services, well, you're going to get the hardware resources of a $55 computer. And so this is one of those things where you can get like weird bottlenecks in infrastructure, where again, somebody installed this kind of thing, 2-3 years ago before your company really started growing. You went from 10 employees to 200 employees. And for some reason, the systems in the network went from being incredibly, incredibly fast to dog slow. And the reason is because now when you have 200 computers and they're all trying to pull service packs from a micro SD card, that might be a wee bit slower than the gig internet fiber connection that the company has, right? And that's where you can actually build your own weird ass bottlenecks into systems. And so something to be thinking about with these caching systems is to make sure that you provision hardware that is appropriate for the load that these systems are going to be under. Again, don't get me wrong. You got 10 users in an office, Raspberry Pi is probably going to be fine for caching. It's probably fine for Active Directory, to be honest with you, if you can make Active Directory work on it. But anyways, but once you start, having more and more load, what you might find out is this becomes the bottleneck. If you do not document things properly, if you don't make sure the other IT staff knows what's going on with your infrastructure, this is one of those places where you can add some weird problems into your systems without anybody realizing what's going on. Basically, you have folks and they're doing ping tests to Salesforce, and they're doing speed tests. They're doing all this stuff. Everything seems to be working fine, but nobody's computer is updating properly. And again, an intern or somebody installed a SQUID caching, what's it called? A SQUID transparent caching proxy server, I think is the appropriate name for it. People don't realize it's there, and it's a big pain in the butt. So that's one of the things to be thinking about with this is do not under provision hardware resources for caching, because that really can bite you in the ass. So there you go. There is a long-winded discussion about caching and systems architecture. Again, I actually think this is a really important concept right now. It's interesting to be in the technology world and see like that whole concept of what was old is new again, right? So I've been doing technology since 1996, started in the Army, doing electronics repair, again, got my MCSE back in 2000, blase. And so that's the thing, as I remember proxy servers, I remember when proxy servers were a really big deal because we didn't have NAT. We did not have network address translation. So if you had 10 computers and they're all trying to share one person's 56K connection, which I'm not lying, that used to be, you used to go to internet cafes, and internet cafes would have one computer with a 56K modem, and 10 other systems would be piggybacking off that damn thing, right? So anyways, again, proxy servers and caching proxy servers, again, you go back to like 1999 or whatever, something like that, they were really important, especially for the end users. Just something as simple as being able to share an internet connection. Then we got NAT, we got something called network address translation that was built into basically all the modems and the internet routers that we have nowadays. What that allows you to do is that allows all your local computers to share one external IP address. When we talk about external IP addresses, that's where NAT comes in now. And again, for 15 years, people forgot about proxy servers and caching and all that kind of stuff because it really didn't matter too much. Now, again, we're in this world of service-oriented architecture where we're going to create systems, and my system is going to be talking to OpenAI, and my system is going to be talking to Twilio, and my system is going to be talking to different data stores, and my system is going to be pulling in RSS feeds. My, quote-unquote, my system now actually relies on a whole bunch of information getting pulled in from other APIs. Now, all of a sudden, my overall system can be slowed down if somebody else's systems are not up to snuff. Again, somebody didn't pay the utility bills or whatever else. So in this modern world, adding caching into your architecture can be a very valuable thing. Again, it saves you money. Every time you do an API call, it might cost you a penny, it might cost you a fraction of a penny, but at scale, fractions of pennies can add up to millions of dollars. You can save a little bit there. That can be very useful. Again, latency and lag. Every time you have to make an API call, it is going to take longer to make an API call than it is to access your local database. It's just how it is. Again, from a security or privacy standpoint, every time you make an API call, that API provider can log a crap ton of information you may not be thinking about, and they can sell it to China or whoever else. And again, as long as a huge amount of money passes hands and a publicly traded American company is the one that profits, it's patriotic. Again, TikTok is evil because it's Chinese. This crap is patriotic because I don't know, but it's true. Again, like I'm not even joking. Intelligence agencies are actually buying this crap. Like they can literally buy this information, just buy it, right? So again, you want to mitigate that type of thing. That's something for you to consider because again, things like your competitors might buy that information, right? Again, when you're thinking about competitors, you might be thinking about your competitors. Right? Oh, I created this little app and somebody else created this little app. Eli, they don't have the budget to buy information about who's using my app. Yeah, but Facebook might. Right? Again, and this is one of the things you have to think about in the modern world, right? Silicon Valley. I have a lot of issues with Silicon Valley. I think one of the problems is, right? They're how they do business is so screwed up. Just they literally attack their own customers. If they have a customer and that their customer comes up with a really good product that's getting traction that happens to use their platform for whatever reason, they'll just copy and destroy that app. They just do, and they don't think twice about it. Of course. Of course, right? And so that's one of the things to be thinking about, right? If you're using an app that's using Facebook or something else, you may want to keep it on the down low about how many API calls or whatever that you're making and keep it on the down low so that, again, Facebook or Amazon or Microsoft can't buy basically what it is, intelligence information about how well your app is doing so that they can, try to destroy you. Because in our modern world of Silicon Valley, these Silicon Valley companies literally don't have much of an issue with destroying their own customers. Which again, have I said I don't understand? There's so much stuff I don't understand in the modern world. So anyways, that's why all of this stuff can be pretty useful. So if you missed it before, again, my main channel, Eli the Computer Guy, at least for all of 2024, and most likely going into the future, what I'm going to be doing is I'm going to be building projects there that show you how to use these technologies, again, in the real world, AI, IoT, robots, quantum computing, all this kind of stuff, actually showing you what this stuff does, so that at least when you have a damn argument about it, you're not arguing about fantasy land, right? Right? So I'm doing those classes over there, and that's where a lot of these concepts, when I do these seminars, that's where a lot of these concepts are going to be coming from. Basically, as I build out those classes, there's a lot of concepts that go into them, so I figure I'll flesh out those concepts here. So yeah, that's about all there is. As always, I enjoy doing this particular video, and I look forward to seeing you in the next one.